Simplify means make it simpler, all right? And what we've got here is three monomials. There's 3xy in one parenthesis. We've got 9x to the third power in the middle parenthesis, and x times y to the fourth power in the last parenthesis. And what we want to do is combine those all into one simplified expression involving exponents, all right? So this is basically what this one's about. What do we do with the exponents when it's all a multiplication game, all right? So let's take a look at this problem. Let's see how it's going to work. First of all, I'm going to let you all write it down at home, and I'm going to write it down here a little bit bigger on the screen, and so we can look at each of these blocks in themselves. You heard me use the word monomials. This is a monomial. Basically, it looks like a clump of variables and a coefficient. Doesn't even have to have a coefficient. If there's not one there, there is a 1 in front of it, all right? So there's one monomial. Here's our second one. This says, wow, 9x to the third power, all right? And that's what we've got happening. And then last but not least, our third monomial, which is x times y to the fourth power. Remember, when we got these variables jammed together, they are multiplication, all right? And since there's no plusing or minusing in between there, we are all about the multiplication here, all right? Rules for multiplication, real simple, real simple. What we're going to do is we're going to take and multiply any coefficients together. Now, my coefficients in this problem are 3, 9, and there's a 1. Now, whatever you do, do not add 1 to the final answer as a multiplication, all right? So we want to make sure we don't make that little mistake. But here's where we start. We're going to say 3 times 9 times the 1. That's going to give us a big 27. Now, this is going to become our coefficient of the final term. Now, the next trick, once we've gotten the coefficients taken care of, that's lovely numbers out in the front, is what we're talking about. Now we're going to see how many x's do we have to play with here. We've got one x here, or x to the first power, so we've got an x that we're dealing with. We're going to multiply that into another x, actually an x to the third, and then we're going to throw one more x its way. So what we're doing, we're looking at exponents being 1 and 1 on those two marks right there. Okay, they're understood. It's understood. Just like it's understood, there is a 1 in front of that coefficient. There's a coefficient in front of that expression right there, okay? So let's do some multiplication. By the way, that is not a minus. Those of you who are just now tuning in, these are all multiplications, all right? So what we're going to do with the exponents is put them all together, all right? So the variable x, we counted 1 plus 3, which gives us 4. Add one more to it. How about 5? X to the fifth. And then our y, once again, remember, if we don't have 1, we've got a 1, all right? If we don't have an exponent, we have a 1 on it. And there's no y's together dust here, so let's go and pick one up here. We've got an exponent of 4. Add those exponents, 1 plus 4. Wow, you're probably going out there. Does it always come out to 5, Ernie? No, just happened to do it on this problem, okay? But check once again, 3 times 9, rehash here, times 1 gives us 27. Add your exponents, 1 plus 3 plus 1, that'll give you the x to the fifth, and 1 plus 4 gives you y to the fifth. Nice problem of the day, exponents, exponents. It's funny because when you're using those multiplications, you think you should multiply exponents. No, you add them together. You're collecting them together, so to speak there, all right?
For more math help, visit TNLearn.org.